Hello friends, welcome back to my channel. Today we are going to learn differentiation of composite function with the help of these 5 examples. Our first example is y is equals to under root of sine x cube. Write differentiation with respect to x. Second step is put d by dx on both sides. Consider this sine x cube as x and solve its differentiation using root x differentiation formula. Differentiation of root x is 1 upon 2 root x. So its answer will be 1 upon 2 under root of sine x cube. And we have considered sine x cube as x. So we need to take derivatives of sine x cube. Now consider x cube as x and differentiate sine x cube with the help of sine x formula. Differentiation of sine x is cos x. So next step will be 1 upon 2 root sine x cube into cos x cube into, now we need to take differentiation of x cube. We can solve x cube derivation with the help of x raised to n formula. So differentiation of x raised to n is n x raised to n minus 1. We get cos x cube upon 2 root of sine x cube. Differentiation of x cube will be, here n is 3, so 3 into x raised to 3 minus 1. Final answer will be 3x square cos x cube upon 2 root sine x cube. Our next example is y is equals to cot square x cube. First write differentiation with respect to x. Now put d by dx on both the sides. We can take this square to the bracket square. So it will be d by dx of cot x cube bracket square. Consider this cot x cube as x and use x raised to n formula to differentiate cot x cube bracket square. So x raised to n formula is n x raised to n minus 1. Now here cot x cube is x and 2 is n. So our answer will be n, that is 2, into x is cot of x cube bracket raised to n minus 1, that is 2 minus 1. Now we need to take differentiation of cot of x cube. Consider this x cube as x and solve it with differentiation of cot x, and it's minus cosec square x. Next step will be 2 cot x cube as it is, and bracket raised to 2 minus 1 is 1, so it's cot x cube into, now differentiation of cot x cube is minus cosec square x cube, and we need to take differentiation of x cube. We can put negative sign at the start, so minus 2 into cot x cube into cosec square x cube. Now differentiation of x cube, we can take it with the help of x raised to n formula. Here n is 3, so its differentiation will be 3 into x 3 minus 1. Final answer will be, we will multiply constant, 2 into 3 is 6, so it is minus 6. Here x raised to 3 minus 1 is x square, so minus 6 x square cot x cube cosec square x cube. Our next example is y is equals to log of cos x raised to 5. Write a differentiation with respect to x. Put d by dx on both sides. Consider cos x raised to 5 as x and differentiate with differentiation of log x formula, and differentiation of log x is 1 upon x. So now we can write 1 upon cos x raised to 5 into, now we need to take differentiation of cos x raised to 5. Consider this x cube as x and differentiate with differentiation of cos x formula, and differentiation of cos x is minus sin x into minus sin x raised to 5. Now we need to take differentiation of x raised to 5. This x raised to 5 can be solved with x raised to n formula. So differentiation of x raised to n is n x raised to n minus 1. We will put minus sign here at the start. Then sin x raised to 5 upon cos x raised to 5 into differentiation of x raised to 5 will be 5 x raised to 5 minus 1. Sin upon cos means tan, and here theta is also same, so we can write minus tan x raised to 5 into 5 and x raised to 4. Final answer is minus 5 x raised to 4 tan x raised to 5. Next example is y is equals to x cube plus 2x minus 3 raised to 4 into x plus cos x cube. First step is write differentiation with respect to x. Put d by dx on both sides. Now here we can see that two terms are in the multiplication. So we need to use multiplication formula, that is differentiation of u into v is u derivative of v plus v derivative of u. Here consider first term as u and second expression as v. Write u as it is. We will take differentiation of v, that is differentiation of x plus cos x bracket cube, plus we will write second expression as it is, that is x plus cos x bracket cube, and we'll take differentiation of u, that is x cube plus 2x minus 3 raised to 4. Consider this entire expression as x. We can take its differentiation with the help of x raised to n formula, and differentiation of x raised to n is n x raised to n minus 1. First we will write this expression as it is, that is x cube plus 2x minus 3 raised to 4 into differentiation of x plus cos x raised to 3 will be, here n is 3, so 3 into entire expression, that is x plus cos x raised to n minus 1, that is 3 minus 1. And now we need to take differentiation of the expression, that is x plus cos x. Our next expression is as it is, that is x plus cos x bracket raised to 3, and differentiation of x cube plus 2x minus 3 raised to 4 is, here n is 4, so 4 is 4 into entire expression, that is x cube plus 2x minus 3 raised to 4 minus 1 into differentiation of x cube plus 2x minus 3. We will write first expression as it is, that is x cube plus 2x minus 3 raised to 4, 3 into x plus cos x bracket square, because 3 minus 1 is 2, and differentiation of x plus cos x. So here we know that in addition we separate out the differentiation, so we will separate the differentiation, that is d by dx of x and d by dx of cos x, plus sign as it is, then bracket as it is, that is x plus cos x raised to 3 into 4 into x cube plus 2x minus 3 raised to 4 minus 1 is 3 into, again we will separate out the differentiation here, so differentiation of x cube plus differentiation of 2x minus differentiation of 3. Take 3 at the start, then x cube plus 2x minus 3 raised to 4 into x plus cos x bracket square, and now derivative of x is 1 and derivative of cos x is minus sin x, So it will be 1 minus sin x. Similarly, we have taken 4 here. Then our expression x plus cos x bracket cube into x cube plus 2x minus 3 bracket cube. And now derivatives of x cube, we can solve it with x raised to n formula. Here n is 3. So in x raised to n formula, its answer is nx raised to n minus 1. That is 3 into x raised to 3 minus 1 plus here 2 into x is there. So first we will take 2 outside because 2 is constant and derivative of x is 1 minus derivative of constant, that is 3, is 0. Next step is 3 into x cube plus 2x minus 3 raised to 4 into x plus cos x bracket square into 1 minus sin x plus 4 into x plus cos x bracket cube into x cube plus 2x minus 3 bracket cube into 3 x raised to 3 minus 1, that is 2, 3x square plus 2. So this is our final answer. Our next example is y is equals to 1 plus cos square x bracket raised to 4 into root of x plus root tan x. Write differentiation with respect to x. Put d by dx on both the sides. Now here we have two terms in the multiplication. So we can recall differentiation of u into v is u differentiation of v plus v differentiation of u. Here first expression 1 plus cos square x raised to 4 is u and under root of x plus root tan x is v. Right? First expression as it is, that is 1 plus cos square x raised to 4 into derivatives of under root x plus root tan x plus second expression as it is, that is under root of x plus root tan x differentiation of 1 plus cos square x raised to 4. While taking derivatives of under root of x plus tan root x, here we can consider this entire expression as x. We can solve it with differentiation of root x formula. It will be 1 upon 2 root x. And here 1 plus cos square x we can consider as x and we can solve it with differentiation of x raised to n formula. It will be n x raised to n minus 1. Next step will be 1 plus cos square x raised to 4 as it is. Differentiation of under root x plus root tan x will be 1 upon 2 in under root our entire expression, that is x plus root tan x, and we have considered this expression as x, so we need to take differentiation of x plus root tan x plus sign as it is. The expression is under root x plus root tan x as it is. To find out differentiation of 1 plus cos square x raised to 4, we will consider 1 plus cos square x as x. So its answer is n x raised to n minus 1. Here n is 4. So we will put 4 as it is. Then x is one entire expression, that is plus cos square x raised to n minus 1, that is 4 minus 1. We have considered the entire expression as x. So we need to take differentiation of 1 plus cos square x. First write this starting expression, that is 1 plus cos square x raised to 4 into 1 upon 2 root of x plus root tan x as it is. Let's understand how to find out differentiation of x plus root tan x. So first we will separate out the differentiation because there is addition operation. Now d by dx of x is 1 plus consider this tan x as x and d by dx of root x is 1 upon 2 root x. So it will be 1 upon 2 root of tan x. Now we need to take differentiation of tan x. So 1 plus 1 upon 2 root of tan x into differentiation of tan x is sec square x. So here we will put 1 plus sec square x upon 2 root of tan x plus we'll take 4 at the start, then under root of x plus root tan x 1 plus cos square x raised to 3. 4 minus 1 is 3. Now we will understand differentiation of 1 plus cos square x. Separate out the differentiation. So differentiation of 1 is 0 because 1 is constant. Now we need to consider this cos x as x and we need to solve it with x raised to n formula. It is n x raised to n minus 1 will be 2 cos 2 minus 1 will be 1, so it will be 2 cos x into differentiation of cos x 2 cos x and differentiation of cos x is sin x and it is minus, so minus sign at the start. Here we will get minus 2 sin x cos x 1 plus cos square x raised to 4 into 1 upon 2 root of x plus root tan x into 1 plus sec square x upon 2 root tan x. We can multiply constants, that is 4 into 2 is 8 and here we have negative sign, so it will be minus 8 sin x cos x, then we have root of x plus root tan x into 1 plus cos square x raised to 3. So this is our final answer.